in this section we're going to talk about naming covalent compounds and writing molecular formulas. Now I do want to note here that covalent and molecular are going to be used as synonyms. Okay, so if we say we have a molecular compound or a covalent compound, those are the same. Naming covalent compounds and writing molecular formulas, we're talking about the same thing. We're talking about covalent compounds. Now, this is so easy, it's almost going to seem silly to even make a video about it, but the hard part about covalent is recognizing when to use covalent rules and when to use ionic rules, and that's really going to be the struggle as we move forward, because we learned how to do ionic and now we're going to learn to do covalent, and they're so different that you may get confused about when to do which one. So as a reminder, covalent compounds are made of nonmetals. In this section, we're only going to talk about binary covalent compounds. So that's a covalent made of two nonmetals. Now, there are covalent compounds made of 3 nonmetals, 4 nonmetals, you know, as big as you can think, really. And they have their own naming systems, and sometimes they don't even really have names related to the formula. Just people will come up with common names for them. But what we're looking at here and what we're going to focus on in this class is just 2, and that's all you'll ever be responsible for. Alright, so, very simple. You're going to have 2 words, because you have 2 elements in a binary compound. So you'll have 2 words, and those words will have prefixes. So, if you have one of the first element, you might use mono, di, tri, tetra, penta. Okay, so those are our prefixes. Those are the same prefixes that we saw when we were doing hydrates. Alright, so there's our prefixes. And then, how does this work? The first word, so you got 2 words, the first word takes the name of the element with a suitable prefix. So I want to do an example here. I'm going to do N2O5. Okay, so there's my compound. So I name the first element and then the suitable prefix in front. You know, pre comes before, so this would be called dinitrogen. Right? Then you name the second one, but you end it with "ide." Just like we did in ionic, the second one is going to end with "ide," and you'll still use your prefix. So dinitrogen pentaoxide. Okay, dinitrogen penta, and then I changed the ending, pentaoxide, for example. Now, there is one rule, and it's really the only trick here. The prefix mono is not ever used on the first element. So, for example, CO2. Okay, that's a common compound. We've got 1 carbon and 2 oxygens. So we would say carbon dioxide. Dioxide. We wouldn't say monocarbon dioxide. Mono is not used on the first element. However, if we have one of the second, like if we have CO, carbon monoxide or monoxide, depending on how you spell it, carbon monoxide. So we're going to use that prefix for 1 only if there's one of the second one. We wouldn't use it for the first one. Alright, so we'll look at a few examples here. These are all covalent. They start with a nonmetal and end with a nonmetal. There's no metals in there. Okay, so those are covalent. So we have silicon dioxide, carbon monoxide. Notice these both have 1 of the first one, so we don't put a prefix. Carbon, there's 4 fluorides, so tetrafluoride. Alright, that was 1 carbon, so no prefix, but here there's 4 nitrogen, so tetranitrogen. Don't change the ending on that one. Tetraoxide. Okay, tetranitrogen, tetra. Notice our endings, ide. Alright, xenon. This is a noble gas, which usually doesn't form bonds, but sometimes the big noble gases will. Xenon, here's a 6, xenon hexafluoride. Dinitrogen trioxide. Here's a 4, that is tetra, tetraphosphorus heptaoxide. Alright, so you get the idea. We're just naming and adding prefixes as needed. Now let's go the other way. Carbon dioxide. Now remember, on ionic we would look at our charges and then make sure they were balanced or crisscrossed if we needed to. You do not do that in covalent. Just let the name tell you what the formula is. Carbon dioxide, CO2. Phosphorus trichloride, 1 phosphorus and 3 chlorines. Sulfur tetrafluoride. There's no prefix on the first one, so that means there's 1 sulfur and then 4 fluorides. Disulfur, so 2 sulfurs, dichloride, 2 chlorines. Iodine, no prefix, so there must be 1 monochloride, so 1 iodine and 1 chloride. Dinitrogen tetraoxide, 2 nitrogens and 4 oxygens. And nitrogen, no prefix, so there must be 1 triiodide. Alright, very, very simple. Once you get done with this, you'll do the worksheet that goes with 2.2. The first one and the second one are for covalent compounds, and then they're going to mix them up on you. So on number 3, be very careful. Figure out if it's covalent or ionic, and then solve.